Okay, let's make this fast so that you can have as much time by yourselves, yeah? As a reminder, even here, even now, all we're doing is look at TOA. Okay? You're going in to an unknown, unusual, maybe unfamiliar circumstance as you read a word question. But at that point, I just need you to know that we're still doing SOHCAHTOA. We're doing the same stuff every single time. Find your triangle, identify if it's opposite adjacent hypotenuse, find what ratio you're going to use, and then solve it. Okay? Let's talk about this. I think I remember mentioning whether you saw people that were doing this all around Yonge and Eglinton. Because you see it quite often because Yonge and Eglinton is almost always under construction, right? Even my high school days were spent in Yonge and Eglinton area. Yes, I went into one of the schools here, and don't worry about it. I went to North Toronto. I know, it's okay, We don't like Northern either. But surprise, I'm here. But even then, there was so much construction. This was before you see all the condos, so it was like 20 years ago, right? It was a long time ago, but even then, there was so much construction going on here. Your goal is to read these situations and find your triangles. Find your 90-degree triangles. Even if this question sounds confusing, you're supposed to find the triangles and then solve it to the best of your ability. Here's a question. Okay, so your goal, expose yourself as much as you can, and then raise your experience in your sketching ability so that you can calculate. What do I mean? Let's take a look. A surveyor at point S, so you are right here at point S, that's you, okay, uses a laser transit and marking pole to sight two corners, A and B. Here's A, here's B, on one side of rectangular lot. So that's a lot. You don't have to worry. The surveyor marks a reference point P on that line of AB so that the line from P to S is perfectly 90 degrees to AB. Corner A is 150 meters away and 34 degrees east. Corner B is 347 meters away and 69 degrees from west. The question is, I think it must have been cut off. The question is, what is the distance of AB? So what is AB? Did you add that in there? That's my question. Unusual, yes. But as I said, do you see the 90-degree triangles and how can we use that to help solve this question? The question is, again, what is this distance? I'll let you think about it for another 10 seconds. Well, you might have begun with the thought process of, whoa, that's not a 90 degrees. I can't do anything with that. However, that's the whole point. In blue, I will color this as one triangle. I'm going to color this as one triangle. And in green, I will color this triangle. There are two right-angled triangles. If I can calculate this side right here using my SOHCAHTOA, if I can calculate that side right there using SOHCAHTOA, then the blue check mark plus the green check mark, there's my length. So there's always a method to the madness. There's always a way. Just got to think about it a little bit. So in blue, let's begin. Blue. This is my triangle. I'm going to hyper focus on this triangle only. My angle here is 69. My hypotenuse is 347 meters. I'm coming back to you, Cameron. What side are we looking for?
What side are we looking for?
Yes. Yes. I'm looking for this side right there. And that is my opposite side. That's step one. The hardest part, in my opinion. Making that connection, looking for the triangle and setting up the sides. Okay. With that, I think you will agree that we are looking for this side. We have this side. Here's my angle. This is going to be my hypotenuse, as I mentioned. What ratio should we set it up with? Opposite hypotenuse. Sine of 69 degrees is equal to opposite. Let's give it a letter. I don't want to write OPP. Let's just call it X. Okay, is opposite over hypotenuse. So I'd rather not have sine there if possible. So I will calculate sine 69. So 0.9335. So I'm going to round it 934 is equal to X over 347. And therefore, my X is going to be a multiplication of 0.934 times 347. At this point in time, I hope you will see the connection. Can you essentially do the same steps for the green triangle? And again, just to remind you, why are we doing this? Well, if we have the blue edge, we have the green edge, we can add that together to figure out what that entire distance is. Can I give you 3 minutes this time? Try it. Set up opposite adjacent hypotenuse, figure out what ratio to use, and solve. I'll at least catch up to where you are. So here's my thought process. All right, here's my angle. I have opposite that I want. I have hypotenuse already given. It's going to be sine. And because I am lazy, I am skipping up the setup. I'm just going straight in and substituting the numbers. Oops, that's not degrees. Okay, that's meters. And because I don't want to have sine as is, I am going to multiply that out. Sine of 34 is equal to approximately 0.5591, so just 9. And so I will multiply both sides by 150 to get rid of it. So I've got y is equal to 83.8789, so 879 meters. So again, you could be a little bit off depending on how you rounded it, but the total distance from A to B, so A to B is going to be x plus y. 83.879 plus 324.098. 407 meters 977. Okay, which sort of makes sense, right? If you look at this, it's clearly a lot longer than this one. Maybe it's not proportional, but 324, 83, it seems to fit. The blue line is obviously much longer than the green. Yep. Again, it could be simply from the rounding. So small discrepancies are okay, depending on what you put in as your decimal. All right, let's continue on. The next question is going to be a bit of a challenge. Forget the math. I'd like you to read this question and see if you get the same picture that I'm going to draw. The next example that I'm giving you is to show you how important it is to read and sketch your triangles accurately. So don't do the math. This one is a drawing homework, a drawing task, okay? It's like arts class. Read this section and see if you can draw the bridge accurately with respect to a helicopter. So this is my terrible helicopter. Okay, see if you can draw the scenario. I'll give you a minute. It'll take you more than a minute, I think, to actually read and figure it out. So let's take some time. Okay, so again, bridge being here, I'll read the question carefully and highlight some of the more important parts. They're taking pictures from a helicopter hovering 720 meters above, and then also 1 kilometer horizontally from the west. And the skyway spans a distance of 2650 meters from east to west. From that alone, if you thought about it carefully, you might have reached this conclusion. This portion is going to be, let's do it in meters. That's 1,000 meters, 1 kilometer, right? The entire distance from east to west of this bridge is 2,650 meters, which also will tell you that this distance is 1650 from simple subtraction. Next, I also know that the height directly above the bridge is 720 meters. From Karen's position, what are the angles of depression to the nearest degree of the east and west ends of the bridge? Angle of depression means, what's this angle? Angle of depression means, what's this angle? So I'll call this alpha. So this is great, but look at the angles that we're interested in. Can you tell me, or can you find the triangles we can use? Yep. The one like right here. We could use this, sure. Anyone have a different suggestion? You could also create an imaginary triangle here, because that's what the beta is already. Let me explain. If we did it Maria's way, which is totally what I did in first, you know that this is a horizontal line and the bridge is a horizontal line, which means this angle is the same as this angle. Do you remember in the beginning of this unit, we did the PLT parallel line thing? No? Well, we did cover that a little bit, but think about it this way. Using my dotted line here, and then using the solid line I drew, and pretending there's a height, we actually already have the information we need. What is that distance from the helicopter to this corner? We already have it. Anyone? Think carefully, going once, The distance from here to here is 1,000. Why? Because the base of this triangle is also 1,000. We can make the argument that this and that are exactly the same. You can also make the argument that the height, the vertical distance of the helicopter from the bridge is the same as this edge right here. So I know that this is going to be 720 meters. Yes? Well, the reason I'm trying to focus on that triangle is, let's pretend I solved this triangle. So this is 1,000 and that's 720. By solving this, you were able to get this angle, correct? Or you can also get this angle right here. You would still have to use whichever angle to calculate what this angle is. Why? The question says, what are the angles of depression? So in other words, they're looking for this angle. So it's important to know what angle that they're asking for. So let's focus. I'll draw this a little bit neater. Draw it one more time. Here is the distance, the height from the bridge to the helicopter. This is the horizontal distance that is similar to the spanning horizontal distance of 1 kilometer west end of the bridge. So this is the same, and that's the same as a 2.7 group. If I am going to calculate the angle of depression, I already know that the vertical height of the helicopter is 720. I already know that this base is going to be 1,000. So then I can argue that for the upper triangle, this is going to be 1,000. That's going to be 720. Opposite, adjacent, you can use, yes. Go for it. Tangent of this angle is going to be opposite over adjacent, which means tangent of this angle is equal to 0.72. Angle is going to equal the inverse. I brought the tangent to the other side. In other words, I removed the tangent from the angle. I did the inverse of tangent to both sides. And plugging that into the calculator because there's no other way to solve this per se. Inverse tangent of 0.72. Get ourselves 35.754 degrees. So this angle of depression is 35.754 degrees. Part 2, you can do the same thing here. If I know that the height of the helicopter is 720, I also know that the base of this triangle is 1,650. Well, then I know that the top of this rectangle is 1,650, and this height is also 720. My question is, find me this angle of depression. I'm not going to finish this question because it is an application very almost identical to my blue section. My only reminder to you will be, these are the sides I'm given, and that's the angle I'm looking for. Go ahead and solve it. Yeah. Now at this point, I'll leave this up here, but at this point, I am going to leave the remaining class time for you to try and practice, practice, practice. I don't have anything else for you. It's just getting practice with these word questions. So I'd like you to use this class time as best you can. One last thing before I set you free for today. Please go to the next page and cross out example 4. What I mean by that, not example 3, you can do example 3, but example 4, I want you to cross out. I don't need you to do that one. The answer key for examples 1, 2, 3 is going to be up on our Google Classroom very shortly. Please use that to your utmost. And that's it. Anyone have any questions? No. All right, I'll stop it right here.